Air is actually mostly nitrogen.
Wait, is it gonna blow up?
Is it, Mr. Yano, is it going to blow up? She's a little...
Nope,
okay.
it's not going to blow up. It's actually going to do the opposite of blow up. Okay, so this liquid nitrogen is again minus 320 degrees. So again, we can do a physical change just like we did with the water, only instead we can do it on air. Okay? So, what happened to the air? Okay, now if it was a chemical change, it would stay like that forever, right? But it's not a chemical change, it's a physical change.
So when it freezes, what happens to the particles? They get closer together for the... Yeah, they condense. They take up less space.
So, because it's physical change, it's going. It will go back to exactly where it started from.
Is that cold?
It is cold.
Kale?
Anybody want to stick their tongue in here and have it go through a physical change?
Yes.
No thanks. Chemical.
It's again a physical change. Your tongue would go back to normal. Unfortunately, since your tongue is living, it's probably going to die in the process. So again, guys, we can make it really small. It's steaming too much, but if you could see inside there, you could actually see the liquid air down at the bottom. But it's steaming kind of a lot. So yes, it's cold, but it will eventually get back to the system. It's not going to pop because it's going to go back to the exact same size.
Unless you step on it, Owen.
No, don't step on it, guys.
What are the cool stuff? So, since anybody know how much your body temperature is?
90 degrees. Wait, 98.6.
This liquid nitrogen is minus 320 degrees. So, if you immerse anything, your finger in here, it will freeze and it will freeze off. Okay? So, question. If Kale holds his hand out and I pour this on him, what's going to happen?
It'll freeze off.
No, it won't.
Nothing. It's hurt.
You won't have a hand in here.
And you have to sit here.
Sublimation.
Who said that? It's not sublimation.
Does it hurt?
CO2, dry ice, sublimes. Okay, which means goes from, you know what sublime means?
It means that it goes from liquid to gas.
Not liquid to gas.
Or I mean,
Solid to gas. So this is already liquid. So liquid nitrogen actually does a sublime. Okay. Now the reason why it doesn't hurt is because the nitrogen is so cold, guys, that it actually evaporates before it can burn his skin. Okay. Okay. So.
Oh, I got one right
do you feel anything?
I know.
If it soaks into your hair, though, that's a bad thing.
Oh, I want it. I want it.
Oh, geez.
It's like spring.
A little bit. No.
Oh, wow.
There's ice. Because we got the water in there.
I know.
He just straight up
So we
poured
got a
it.
little burn. Is it?
Little
Not
burn?
going on my watch. That's just a burn.
Yep. It's not even a burn.
Oh, you popped it.
Oh, it tickles.
Oh, it does.
I know. It like little bit. It feels. This is some water right there. Put it in there and see how long it gets. Oh wow.
Pick up your Cheeto bag.
Like that is burned. Oh, cool. It doesn't burn.
No, that was cool. That was
freezing.
What did it feel like? Felt like
This stuff.
it didn't hurt at first. Then that's sweet. Oh yeah, that does hurt.
All right. Well,
Back up for a second.
what are the physical properties of this tube?
Feel it. Dude, it's still warm. Feel it.
Describe it.
It's extendable.
Extendable. Is it hard or soft?
Soft.
Is it stiff or
Wait, did that go in it?
what's gonna happen if
It'll get hard. It'll break.
it might break
Get
if we
hard.
hit it real hard?
It looks like a niggle.
Point is, like, for example, did you know you can freeze rubber too?
Yes.
So you can take a tire, just put it in there.
Freeze everything.
Is that?
You can take a tire, just
Now,
put it in
the
there.
particle's frozen. I'm sorry, what'd you say?
You can take a tire, just put a bunch of that on it. No freeze.
It would freeze. Okay.
found a tire in our creek yesterday.
Found a tire in your creek.
Yeah, there are a lot of them around our creek.
Now, unfortunately, guys, I'm gonna have to dump this nitrogen out because there's water in it. The nitrogen is actually warming up when I pour it in here, so it's not as cold as it normally is. But you know, you can kind of feel it a little bit. Don't hold it for too long, but now it's hard, right? It's basically frozen. Okay. Now, rubber was already a solid. Okay. So the point of this is, even though it's already a solid, so it's not really that it froze, because it's already a solid. It's just that it changed its physical properties because it got really, really cold. Like your teacher, Mrs. K, said, what happens when particles get really, really cold? Do they get farther apart or do they get closer together? They get closer together, right? And that's why it gets hard.
Whoa.
Probably gonna kill the grass. All right. Couple things. Who has seen this demonstration before?
Seabass has and Zoe has.
Don't answer. If you've already
And
seen it
Kaylin.
before, don't say anything. Which of those two is? Pass them around. Again, if you've already seen this, don't say anything.
I can't remember.
I've seen it. I've seen it. I'm just going to keep.
You want to feel it next?
Send them to me. Send them to me. That's a Wixie episode.
Metal and
All right. So, which one's colder?
the metal.
Why?
Because it keeps it inside it.
What's that?
It keeps the coldness inside the metal.
The answer actually is they are exactly the same temperature. Okay. The reason why the metal one feels colder is because someone said it's a conductor, and it actually conducts the heat away from your skin. Okay, where the other one is a piece of plastic and it's an insulator. Yeah.
Is it cold?
Now, if we put a cap on it, that would explode. We're not going to put a cap on it. Who had Mr. Prince last year?
Yes.
We were going to try to do a.
Yes, the
Unfortunately, the board wouldn't allow him to do it, which is understandable because that's creating an explosion. So again, guys, it froze the water on top, okay, and eventually it'll try to freeze all the water down below. And probably pour enough from the top. Probably.
Sorry. Yeah, I know. That's all like that. Oh, jeez, it got on my shirt. It got on my pants. It got on my pants. Oh my God. It's not wet.
Okay, again, you guys see it racing around? It's so cold that it's trying
It's
to.
not wet.
It's actually evaporating right off the table.
I know it did. It got into my shirt.
Can't freeze it all. I probably don't have enough to freeze it all.
That's what did to my pants. Yeah, I know. It got on my pants. And my pants aren't even wet. So this is Send it.
Now I'm turning it. Oh, that does feel good. I won the second.
Oh, it is.
Do I keep these as a souvenir?
Kel, you should make it.
Yeah.
Owen. You guys finished?
This is so cool.
Okay, we
It is cold.
What would happen if I put that in?
Like a deep fryer. Kale's deep fryer.
What is it?
Like the last
Water bottle
Actually, here.
that we use.
Oh, well, it's not sealed. So,
Oh, Jesus.
actually, you can do that. There's air in here. So, more than likely, I think, you'll seal it. Pull it. It'll probably get smaller. If it doesn't crack and break. It might just crack and break. So, guys, just like the balloon got smaller, you can hear it. It's probably about to crack and break. See how the bottle got smaller too? You can probably pick that up.
There you go, Jared. Now you can see it's frozen.
We're almost getting the whole bottle of water frozen.
Mr. Yano,
Yes.
where do you want these?
You just put them back down in there. Now, if this thing,
Oh, there's ice in here.
Wait, Jared, let me
this
see
thing,
it.
You can eat ice in here.
That's sweet.
It's a teapot. Oh, I need a teapot, sure. Your paper's in here.
so it's actually boiling. When a teapot boils, it usually means it's hot, right? Would you want to touch it? No. You mean it's boiling? Go ahead and touch it. Just try.
I bet he wouldn't set you up.
Is it hot or cold?
Cold.
What the heck? It's boiling. Why is it cold?
Because it's boiling. It's boiling. It's boiling in a different way.
Cold.
I mean, it's like a cold boil.
It's the exact same boiling that boils on your
Don't keep your
teapot.
hand on it.
It's because of the evaporation.
Okay, that's what happens when water boils,
Isaiah.
right?
Make an S.
Okay, but how can it be boiling if it's cold?
The metal's
It's
taking
not
all
cold.
the coldness from the nitrogen.
I
Correct.
don't know. You tell us.
But how can it be boiling if it's cold? Doesn't boiling have to be
What
hot?
would happen if you took a piece of paper and put it
Okay, so guys, the answer to this is, what is in here that's boiling?
The water,
liquid
the liquid nitrogen.
It's not water, it's liquid nitrogen. So what temperature, if liquid nitrogen turns to a liquid at minus 321 degrees, what temperature does it also turn to a gas?
Same.
Just a hair above. So all the liquid nitrogen has to do is get to like at minus 322 and it will start to boil. Okay? So it's inside here is liquid nitrogen that's boiling.
It's always